Okay, chemistry today. Another flip session of a gas law. So today's gas law, we're going to be talking about Charles's gas law. And Charles's gas law relates volume of a gas to its temperature of the same gas under constant pressure. Right? So how does volume change in response to temperature change under constant pressures? Okay, so I just said that, right? It compares how gas volume responds to a change in temperature with P being constant. Temperature and volume is a direct relationship. As we increase the volume, or the temperature of a gas, rather, its volume is going to change. Think about that for a second. Okay? If you have a container in the microwave and the lid is on that container and you start to heat it up, as the temperature of that food item increases, you're going to pop the cover off of your Tupperware container or whatever you're heating up at that time, right? So it's a direct relationship. Temperature goes up, volume goes up as well, right? As all gas laws, we're never going to use the Celsius scale because Celsius starts getting into negative values, and we don't want any negative volumes, right? It's kind of strange to have a negative volume. So we're going to convert all of our temperatures to the Kelvin scale. And what you have to know with these problems, the way to convert between Celsius to Kelvin is real simple. You simply take your Celsius temperature and you add to it 273.15. Okay, so that's our conversion from Celsius to Kelvin. And once again, why do we use Kelvin? Because there's no negative values, right? The coldest that Kelvin is going to become is 0 degrees Kelvin, or 0 Kelvin, I should say, which is called absolute zero, where particles actually cease to even vibrate, right? So very, very cold temperatures. So let's take a look at one of these problems, okay? Here's Charles's law, right? The volume and temperature under one set of conditions is proportional to the volume and temperature under a second set of conditions, right? So the subscripts tell me my initial conditions, right? So 1 is my initial, and 2 are my final conditions under constant pressure. Okay? So here's our problem. A fixed amount of gas under constant pressure, there it is, changes from negative 40 degrees Celsius to 15 degrees Celsius. The initial volume is 40 liters. What is the final gas volume? Okay, so they give us a couple of variables here. Okay? We change from negative 40 to positive 15 degrees Celsius. So this gas is warming up, and it has an initial volume of 40 liters. So let's plug in here. What's the final gas volume? What is V2? That's what we're trying to solve for. Okay. So if we transpose this equation to get V2, we're going to multiply both sides by T2. So we're going to take that T2 and push it to the numerator on the left side. So let's see what we get here. Okay, first we have to convert our temperatures from Celsius to Kelvin, as mentioned before. So negative 40 Celsius plus 273 is going to get you 233.15 Kelvin. So that's our first temperature. Right? I don't want to use this negative because it's going to give me a negative value. 15 degrees Celsius for temperature 2. Add 273.15 and we get 288. So if we simply transpose this equation from V2, we get this. T2 times V1 over T1. That got faded a little bit. And we plug in, and notice what happens here. The kelvins, they're going to cancel. So we're going to be left with what we want, right? With liter. So our new volume is going to be 49.44 liters. Now let's think about this for a second. Okay? This is at a temperature of 288.15 Kelvin. Look at our original temperature here, 233. That's cooler than 288. And since it's a direct proportion, if my volume has increased, so does my volume. If this gas is getting warmer from 233 Kelvin to 288, its volume is also going to increase. You see that? From 40 liters to 49.44. So this gas is expanding. It's getting warmed up. Now, why don't we use negative values, right? Why don't we use Celsius? So what if we kept our original negative 40 degrees Celsius? How would that change our answer? So if we keep our temperatures in Celsius and we plug in, here's what we get. We get a negative value, right? We get a negative volume, which is strange. It doesn't happen, right? Gases take up space. So just remember, when converting, always get that Celsius to Kelvin. Okay, guys, that's Charles's law. Until next time, I'm going to put up another video for you to practice Charles's law practice problems. Just remember his expression and to convert that Celsius to Kelvin. All right, I'll see you in class. Good luck.